Solid-state batteries are the buzzword in the battery landscape right now, hailed as the game-changing technology that could transform electric vehicles and portable gadgets. But do they live up to the hype? The answer isn't entirely straightforward yet. A recent breakthrough from TDK Corporation, a leading name in the electronics sector, might just change the narrative. They've unveiled a groundbreaking material for solid-state batteries that boasts an incredible 100 times higher energy density than current options. This innovation could be revolutionary. Picture electric cars that can cover significantly longer distances on a single charge, or smartphones that can go days without needing to be plugged in. It's an exciting vision, but there's more to unpack. So, how did TDK pull this off, and what implications does it have for the EV industry? Let's dive in and explore. For electric car drivers, the worry of running out of battery before reaching their destination, known as range anxiety, is a major hurdle when considering a switch from gas-powered vehicles. Fortunately, TDK's latest advancement shines a hopeful light on the future of EVs. Reminiscent of the brand's iconic cassette tapes from years past, TDK has developed a new type of battery technology, a solid-state battery. Unlike traditional lithium-ion batteries that use a liquid electrolyte, solid-state batteries rely on a solid material for their internal workings. The solid-state design holds the key to the breakthrough. TDK's innovation boasts a massive leap in power compared to their previous attempts. Imagine a car battery that acts like a supersized gas tank, allowing you to travel much farther on a single charge. This new battery packs a whopping 100 times more energy than its predecessors. Placed inside a smartwatch, the new battery could keep a device running multiple times longer than current battery technologies. For example, the Apple Watch currently lasts up to 72 hours in low power mode before needing a recharge, meaning it could potentially last several weeks with an improved battery. Other potential applications beyond wearables could include environmental sensors, according to TDK. While the initial application of this technology targets smaller devices like headphones and smartwatches, the ultimate goal is to scale it up for electric cars. With this powerhouse battery, electric vehicles could potentially travel a staggering 1,500 kilometers, or about 930 miles, on a single charge. That's more than 3 times the range of most EVs on the road today. This significant improvement would drastically reduce range anxiety and make electric cars a far more appealing option for long-distance drivers. But the benefits extend beyond just range. Solid-state batteries offer a safety advantage too, since they eliminate the risk of flammable liquids present in traditional lithium-ion batteries. Additionally, they may offer much faster charging times, reducing the wait at charging stations and making daily commutes more efficient. Noboru Saito, the CEO of TDK, isn't shy about his enthusiasm for the company's breakthrough. He envisions their newly developed solid-state battery material playing a pivotal role in a large-scale shift toward a more sustainable and energy-efficient future. This technology has the potential to revolutionize the way we power our society. However, the path from breakthrough innovation to widespread adoption isn't always smooth. Unlike conventional lithium-ion batteries that use a liquid electrolyte, TDK's solid-state design relies on a solid ceramic compound made of oxides. This ceramic acts as a bridge for lithium ions to flow between the battery's two components, the lithium alloy anode and the cathode. While this solid approach offers significant advantages, it also presents technical hurdles. Maintaining a stable connection between the solid electrolyte and the electrodes is more challenging compared to liquid systems. Additionally, the entire battery needs to operate under pressure, adding complexity to the design and manufacturing process. And TDK isn't alone. Major car manufacturers, especially from Japan, have been vocal about the immense potential of this technology. Toyota, for instance, has been heavily investing in in-house battery development and aims to bring solid-state batteries to market by the end of 2027. However, this date has shifted multiple times, highlighting the unforeseen challenges in scaling up this tech from lab to mass production. As the future of solid-state batteries unfolds, a new type of battery design called semi-solid-state has emerged as a stepping stone. Chinese automaker NIO exemplifies this approach, offering semi-solid-state batteries as an option on their ET7 sedan. These batteries boast an advertised range of 1,000 kilometers, a significant jump over current EV offerings. The development of solid-state battery technology is a race against time, filled with both promise and complexity. If breakthroughs like TDK's continue, the future of energy could arrive sooner than we think. Companies like TDK and car manufacturers like Toyota appear to be the front-runners in the race for solid-state battery dominance. While technical hurdles still remain, breakthroughs like TDK's new material and the emergence of semi-solid-state batteries offer a promising glimpse into the future. We're standing on the cusp of a transportation revolution, with electric vehicles powered by safe, long-range solid-state batteries gradually becoming a reality. This shift could drastically reduce our dependence on fossil fuels and pave the way for a cleaner, more sustainable future for our planet. But when can we actually expect to see TDK's new battery in the market? Unfortunately, the road to widespread adoption may be longer than many had hoped. Row Motion, a consultancy specializing in the battery market, has tempered expectations, suggesting that mass market availability of this technology might not happen until around 2035. The primary reason: cost. Currently, a typical EV battery accounts for roughly one-third of the vehicle's total cost. However, with NIO's semi-solid-state battery, that figure shoots up to 50%, and a fully solid-state battery would likely cost even more. Ilola Hughes, an analyst at Row Motion, explained that while solid-state batteries have long been a hot topic in the battery industry, there's a consistent theme: delays and missed targets. She emphasized that while technical advancements like TDK's breakthrough are exciting, the true challenges lie in cost and scalability. Manufacturing these batteries needs to become cheaper and more efficient before they can realistically compete with today's lithium-ion options. On top of that, solid-state batteries also face technical concerns. Regarding durability over time, performance in extreme temperatures, and long-term reliability, especially when scaled up for electric vehicles. These aren't just minor hiccups. They're crucial roadblocks that need addressing before we see mass-market EVs running on solid-state tech. Another concern lies in supply chains and materials sourcing. TDK's ceramic-based solid electrolyte may require rare or hard-to-process materials, which could strain global supply lines already burdened by rising demand for lithium, cobalt, and other essential elements. Unless new sustainable sources or recycling systems are put in place, scaling up production may prove challenging. Despite the hurdles, global interest in solid-state batteries remains incredibly high. Governments and automakers alike are pouring billions into research and development. The European Union, for example, has allocated significant funding toward advanced battery tech, while the United States Department of Energy is backing startups and academic collaborations aimed at solving solid-state's biggest pain points. Meanwhile, private sector giants are making strategic moves. Ford, BMW, Volkswagen, and Hyundai have each partnered with or acquired solid-state battery startups like Solid Power and QuantumScape. These companies are racing to develop practical battery systems that deliver the promised benefits: higher energy density, faster charging, improved safety, at a competitive cost. TDK's announcement is a game-changer, no doubt. It shows the tech is evolving, and the ceiling for performance is being pushed higher. Yet, the question remains: when will these innovations reach your driveway or your pocket? Experts believe the timeline will depend on how quickly manufacturing processes mature and costs come down. In the meantime, semi-solid-state batteries will likely serve as a critical bridge. These hybrid designs, like those used by NIO, provide many benefits of solid-state systems, such as increased range and better safety, while being easier and more economical to produce with current infrastructure.